Okay, Chapter 5, Section 3, we're going to be talking about types of simple machines. Now, we just got done talking about machines. Or anything that makes work easier, the ability to make work easier. So a simple machine is a machine that does work in only one movement of the machine. There's 6 different types of simple machines. They're levers, pulleys, wheel and axles, inclined planes, and screws and wedges. Now we are going to be doing labs later this week where you're going to be utilizing these different ideas and the equations from the 2 previous sections, so don't forget those. And here's an example of a pulley. So let's talk about levers. Lever is a bar that has a free pivot about a fixed point or fulcrum. We can see here that we have an effort arm where a man is pushing down on one side, a fulcrum which is being used as a rock, and a resistance which is going to be pushing up on the globe. This is showing that you can move this with one movement. Now note, your effort is downward, but your force is upward. So we have an ideal mechanical advantage for this because we're talking about a frictionless, hopefully ideal machine. And the MA would be increases the MA greater than 1 increase the force. So here we have the lever E is over the lever R. So the E is the effort arm length and the R is the resistance arm length. You can write this onto your equation sheet. The LE must be greater than the LR in order for it to multiply the force. So we want to make sure that you understand that your effort arm length does depend on how far you can lift something. The heavier an object is, the more length you have to have in the effort arm. So we have 3 different classes of levers. Let's talk about the first class lever. In a first class lever, you are going to have a fulcrum between your effort and your resistance. The fulcrum is in the center. So basically, in this case, we can increase the force, distance, or neither. And we can change the direction of the force. So as you push the effort force down, the resistance force will go up. You have a second class lever. In a second class lever, a fulcrum is always at an end, like a baseball bat. Your resistance force is in the middle, and your effort force is at one end. You will always increase your force with this second class lever. Then we have a third class lever. We'll always increase distance. The fulcrum is still at one end, but your effort force is at the same end as your fulcrum, and the resistance force is at the opposite end. So let's go through some problems for levers. So if you use a 100 centimeter plank to lift a large rock, the rock is 20 centimeters from the fulcrum, and the plank, what is the plank's IMA? So there is our little diagram at the bottom for that. So what are we given? We are given the resistance length, which is 20 centimeters. We are given the effort length, which is 80 centimeters, and we need to find the ideal mechanical advantage. So now that we know what we're given, you guys can go ahead and solve this problem. So you want to use the equation for IMA of length effort divided by length resistance. And so it would be 80 divided by 20. And in this case, you get an IMA of 4. So now let's talk about pulleys. We have 3 types of pulleys, but a pulley is a grooved wheel with a rope or chain running along through it. We have our flexible first class levers. We also have our pulleys. And so you're going to see here that we have our force being applied in 2 different. You have an LE, which is your effort force, and then an LR, which is your length resistance as well. So ideal mechanical advantage for a pulley is equal to the number of ropes that support it. So your IMA in this case would be 0. Then we have 1 because we have 1 rope. And in this case we would have 2 ropes. So the first type is a fixed pulley. Its IMA is 1. It does not increase force, and it changes the direction of the force. So you can see it has one attached point to a block at the bottom, and then you're going to have a fixed pulley hooked to something, say a ceiling, and you're going to pull on the opposite end, and that's where your effort force is going to come from. We have a block and tackle pulley system. This is a combination of fixed and movable pulleys. And we have the fixed pulleys are the two here, one here and one here, with a movable pulley down here. This one will actually move as you go through. In this case, it has an increase IMA of 4 because it has 4 ropes. Or it may or may not change direction. Then we have a block and tackle pulley system. Block and tackle is shown with 4 of the ideal mechanical advantage. And with a block and tackle system, you're typically going to have a series of 3 to 4 pulleys within a system together. Then we have a removable pulley. Note that you have your rope attached to a ceiling. Your pulley is going to be attached to your weight, and you're going to be having an effort force in the opposite direction. This is an IMA of 2, and you have multiple forces. It does not change the direction of the force. So for fixed pulleys, the distance you pull the rope downward equals the distance of the weight will move upward. For a movable pulley, the distance you pull the rope upward is twice the distance the weight will move upward. Then we have wheels and axles. A wheel and axle, like in your car, we have 2 wheels with different sizes that rotate together, and they rotate because of a rotating lever called an axle. The ideal mechanical advantage, the effort force, is used to apply to the wheel. The axle moves less distance but with greater force. Here's the equation that you need to put down for your ideal mechanical advantage, which is the radius of the wheel divided by the radius of the axle. Again, this is your effort radius, and this is your resistance radius. Again, your wheel would be your effort, your resistance is going to be your axle. So doorknobs, screwdrivers, faucets are all examples of wheel and axles. Usually the input force applied to a wheel and by the output force exerted by the axle. A wheel and axle is just really a modified lever. The center of an axle is known as a fulcrum. The input force is applied to the rim of the wheel, so the length of the input arm is the radius of the wheel. Then we have an inclined plane. You can write this onto your equation sheet as well. So your ideal mechanical advantage is your length over your height. So an inclined plane is a slanted surface used to help raise an object. So there is your length, and there's your height. Then we have a screw. A screw is simply an inclined plane with a spiral wrapped around the cylinder. The ideal mechanical advantage of a screw is related to the spacing of the threads. The ideal mechanical advantage is larger if the threads are closer together. However, the ideal mechanical advantage is larger the more turns of the screw are needed to drive the same screw into a piece of material. That is also why drills become very handy for this instead of just screwdrivers. The next one is a wedge. A wedge is really a type of inclined plane with one or more slopes. And you can see here you have an effort force being applied to a load. We also have a zipper. These are 2 lower wedges pulling teeth together and 1 upper wedge pushing teeth apart. And so it allows for you to put things together and pull them apart. Then we have compound machines. A compound machine is 2 or more simple machines that operate together to form this compound. A car is an example of a compound machine. You have burning fuel in the cylinders that cause the engine to have pistons that move up and down, which then allow for the wheel and axles to have motion to go forward. And the up and down motion makes the crankshaft move. The force exerted by the rotating crankshaft to the wheels through other parts of the car, such as the transmission and the differential. Both of these parts contain gears. They can help change the rate at which the wheels are rotating, the force exerted by the wheels, and even reversing the direction or rotation of the wheels, causing you to, go in reverse. You will have these videos available to you, but you're going to have some labs. These labs are going to go more in depth on the ideal mechanical advantage of these simple machines. There are 3 labs. In order to go through to the next lab, you must first complete the lab before, which means you have to complete lesson 1 before you can go to lesson 2, and so on and so forth. Please use your time wisely. You may get 4 days in class to work on this, but it goes by very quickly.